Well, this question continues. We found over the page part C, D, and E. The first part of the question stated that a shot put event, a 2 kilogram shot, is launched from a height of 1.5 meters with an initial velocity of 8. So let's put in here, let's put that a 1.5 meters height. It's 2 kilograms. Not sure if that makes a difference. And part A and B was the initial and horizontal speed, which we've already got there, highlighted yellow and green. But let's look at part C. It says, how long does it take the shot to reach its maximum height? Well, its maximum height happens when we go up to the vertical speed, when its vertical speed is 0 meters per second. So that's when we reach its maximum height. So I'll just put here, when vertical velocity is equal to, it will be at the top of its path, its maximum height. And so let's find T. And what we've got here is the formulas are, we've got S equals UT plus half AT squared. We don't know S. We've got V squared equals U squared plus 2AS. This will give us S. And we've got V equals U plus AT. And this is a good equation because we know V, we know U, we know A, and we're trying to find T. So that's the time it takes. So let's use that formula. V equals U plus AT. So the velocity, final velocity is 0. The initial velocity we said was 8 sine 60. I'll just leave it as 8 sine 60. Plus negative 9.8. Times T, which is, we'll take 9.8T across to the other side, 8 sine of 60, therefore T is 8 sine of 60 divided by 9.8. Now we've got an initial velocity is positive, we've got 0, we've got negative. Okay, so let's put that in the calculator. 8 sine of 60, 8 times sine of 60, that gives us about 6.92. Divide that by 9.8, and that is the time it will take, 0.70695 seconds. Let's just say 0.707 seconds to 3 decimal places. Okay, that's part C. What is the maximum height from the ground that is reached by the shot? Well, the maximum height will be S. So here we could find, I'll just put 0.707 seconds. Now we want S. And don't forget, it's already 1.5 meters above the ground to start with. Let's find the extra distance that it can go. So S can equal UT plus half AT squared. We could use that rule. U is 8 sine of 60 times T, which is 8 sine of 60 over 9.8. That's simply 0.707. But I'm just not writing 0.707. I'm writing the actual formula that it comes from. So we've got plus half negative 9.8, and then our T squared is 8 sine of 60 over 9.8 squared. All right, let's see what S gives us here. So 8 times sine of 60 times 8 times sine of 60 divided by 9.8 plus, so that's about 4.897959 plus 0.5 of 9.8, and that's a negative, times 8 times, let's just do this, 8 times 60 sine equals, square that, divided by 9.8 squared, times 9.8 times 0.5. So that's a negative 2.4489795, and let's add 4.897959, and we get 2 point, there's a plane going overhead making a noise, approximately meters. Therefore, we add the initial 1.5 meters that it was above the ground. So our height above the ground would be 3.949 meters. So that's 3 decimal places. Okay. What is the speed of the shot when it reaches its maximum height? Well, the speed, I may as well put this, the vertical speed is 0 meters per second, and the horizontal speed doesn't change the whole time, which is 8 cos 60. The horizontal speed is 4 meters per second. Therefore, combining those components gives us a speed of 4 meters per second in the horizontal direction. And that's the final answer. I hope this has helped. Until next time, stay happy.